Okay, so we continue. So looking at question 6a here, there's a small little equation. So it's an equation in x. So I see x minus square root of 32 equals to square root of 128 minus 5 times x. Okay. And the question says, find the value of x, where x is a real number. Okay. Give your answer in the form a multiple of root 2, where the multiple is a natural number. So we'll see how we get on. So, what are we trying to do here? We're trying to solve for x, so I want to get all the x's on one side. So the first thing we can do is maybe add square root of 32 to both sides, and after that we can add 5x to both sides. Okay, so add 5x to both sides. 5x plus x is 6x, equal to square root of 32 plus square root of 128. And then if you want to get x on its own, you divide both sides by 6. I mean, we end up with x is equal to square root of 32 plus square root of 128 divided by 6. Okay. Now what we're asked to do next is to write this as a multiple of root 2, which looks very unlikely at the moment. You could possibly try and solve this equal to a root 2, but really what you're going to be doing is this is kind of just testing the following. So one of the things about positive square roots is that they're unique. What that means is, say take 100, there is only one number, that's positive number, that squares to give you 100, that's 10. But if you write down square root of AB and square root of A by square root of B, if you square this, by definition you get AB, and if you square this, you get root A by root B by root A by root B. The root A by root A gives you A, the root B by root B gives you B, and so if you square this, you also get AB, and so these are equal. So this is what we need to use here. So what we need to do with the square root of 32, we'll do it separately, is to note that this is that 32 is 16 multiplied by 2, and then we can use this thing. So this is square root of 16 by square root of 2, which is 4 root 2. Okay, and do a similar story for square root of 128. Now 128 is 2 by 64, so this is square root of 64 by 2. Which splits as square root of 64 by root 2, which is 8 root 2. And so therefore, if you just take this to be kind of rough work, we know that x is equal to root 32 is 4 root 2, and root 28 is 8 root 2, divided by 6. 4 plus 8 is 12 root 2 over 6, which is equal to 2 root 2. Now, how do we know? I suppose one of the things that wasn't the case when I was younger was that calculators were quite clever. So I reckon, for example, if you were to substitute all of this into the calculator, I think the calculator can handle it. Yeah, it does give you 2 root 2. Like how else did I know? Well, I suppose, so like how do I magically know to go with this? Have I looked at a marking scheme? Have I remembered some tables? No. The answer is I've just done loads and loads of maths. And the more maths you start the more questions you do, the more different things, you start to just get a natural feeling. And that's what happened here. Although, as I said, you could have just gone into the calculator with this. Now, let us look at the thing. Have we answered the question as asked? Have we found the value of x? We did. Is it a real number? Yes, it is. Is it in the form a natural number by root 2? Yes, it is. This is all good. If you want, you could substitute back in here if you wanted. Okay. Part B. Part 2. So we're given a set here. Now, I think what this question is about is if you just banged this into the calculator and didn't use this, well, that they wanted us to use this. But if you just use the calculator, probably giving you the full marks. But in this question, you'll have to do it. So there's a set here, which is square root of 32k squared, square root of 50k squared, and the k squared is inside it, square root of 128, and finally square root of 98k squared. And that's all in the set. That's written in the question. Okay. K is a natural number here. That's important. If k isn't if k was an integer, you've got some problems, because this is actually well, there's a few. Okay, so this is only true if a and b are positive. If you try and put in -1s or something here, you get into awful trouble. The other thing is that so we're going to use this to break these down. So for example, the square root of 32k squared, we can write it as square root of 2 by square root of 16 by square root of k squared. Now you might think the square root of k squared is always k, but that's not the case. For example, the square root of -2 squared. I don't know if this is, you probably may or may not see whether you can see that or not. This doesn't come out to be -2, it comes out to be 2. So the square root of k squared is k only if k is positive, but the question says that k is a natural number, so this is k. So this comes out to be 4 by k by root 2. And what that means is I can similarly simplify the other things here. So let me see. So what I'm trying to say here is that a is in fact root 32. You can put it into calculator if you want. You get 4 root 2, but this is 4 root 2k. Put root 50 into calculator. I believe you will get, it'll be square root of 25 by 2. It'll be 5 root 2k. 128. Square root of 128 we've seen is 8 root 2, so this will be 8 root 2k. And then the last one, 98, well, square root of 98 is square root of 2 by 49, it'll be 7 root 2. Okay, so this is what's said, and it says, show the mean and the median are equal. Now the median is going to be a little bit interesting, okay? So, the mean, obviously we add all these up and divide by the number of numbers. So I'm going to use some notation, let's say a bar. Okay, so you add all these up. You get 4 plus 5 is 9, plus 8 is 17, plus 7, you get 24 root 2k divided by the number of numbers. I get 6 root 2k. That is the mean of that set. Now the median is the number that splits the small 50% from the large 50%, and what you want to do is put A in order. So the largest element, or the smallest I should say, so A, written as say a sequence, is 4 root 2k, 5 root 2k, 7 root 2k, 8 root 2k. Okay, and so the number that splits them into small and big would be the midpoint of 5 root 2k and 7 root 2k, which would be 6 root 2k. Okay. Now what this, is there any importance here? No, okay, the only thing I'd comment, the mean and the median, one of the situations where they're equal is when the data is symmetric, and this is symmetric. Got a very big, very small, medium big, medium small, etc. That's all I see there. We did use this fact, and the fact that the square root of k squared is k if k is positive. It's a bit more complicated otherwise. Okay, and then what I think is a very difficult question. So I would have done the leaving cert in 2004. And I think there was hard questions on it. And so far I've been doing these questions and I think, oh, they're a little bit easy. This is a little bit harder. This is something that I wouldn't have done until college. Okay, we'll see how I actually get on with it. So it says, prove using contradiction that root 2 is not a rational number. Now, unfortunately, like this isn't something you're going to come up with on your own, even though it's something that's maybe 2,500 years. So what we're going to do is we're going to say, okay, if we assume something and you end up with nonsense, that means the original assumption was nonsense as well. Okay, so now it's saying, it's just looking for the proof. Okay, so assume root 2 is rational. Now what a rational is, so we're assuming something and we're hopefully going to end up with nonsense, and that means that if we end up with nonsense down here, then this is nonsense, and the opposite, well, the what's called the negation of this is true, that root 2 is not rational. So rational number is a fraction where the top and the bottom are whole numbers. We can assume those whole numbers are positive. So this means now any fraction, you can always get it down to its lowest form where the two numbers have no common factors. So for example, if you start with something like 8/6 for argument's sake. 8/6 can be, you can divide above and below to get down by 2 to get down to 4/3, and then there's no more common factors, and then we say that's its lowest form. So assume root 2 is rational and its lowest form is, say, P over Q. So the reason I was saying that, oh, this is 2,500 years old or something, look, you're not going to come up with this on your own on the day, really. You'd be a really remarkable student who would do that. So that kind of means that you have to prepare it, but what you don't really want to do is kind of to learn it off. That's not really where you're at. So you'll just be remembering roughly how it goes. And like, so for me, now maybe, you see, maybe I've gone over this so many times that I kind of remember how it goes. So I think all you really want to remember is, okay, we're going to make this assumption, and then there's just a manipulation. You're going to square both sides. You can do that in a second, but yeah, we'll square both sides. And then once you square both sides, you'll make some conclusions about the numbers P and Q, and then we'll see. Okay, so there's actually two assumptions here. One is that it's rational and that this is its lowest form, but you can always, as I said, okay, we can always do this. Okay, so we'll square both sides. So apply the squaring function to both sides. So if this is true, then this is true. We'll get, now P over Q by P over Q is P squared over Q squared. And then there's another thing we could add in here. So lowest form means that we can take these two things to be natural numbers. So multiply both sides by Q squared. We get 2Q squared is equal to P squared. Now, P and Q are natural numbers. So in particular, P squared is a natural number. And this shows here 2Q squared. This is an even number. So this means that P squared is even. And if you think about it, if you take an odd number, an odd multiplied by an odd is another odd. So P could not be odd because P by P is even. So this means that P is even. Say P is equal to 2K. And now put P equal to 2K into this. Therefore, 2Q squared is equal to 2K all squared which is 2k by 2k, which is 4k squared. Now you can divide both sides by 2. And this implies that q squared is even, which implies that q is even, which implies that q is some multiple of another natural number. So we could say here k is a natural number, L is a natural number. And that means that root 2, and it's worth pointing out that L is smaller than Q and K is smaller than P. So P is equal to 2K, Q is equal to 2L, and then you can divide above and below by 2K over L. Now what this really implies is that root 2 has no lowest form. Because actually what you can do is you can keep doing this forever and ever. So if root 2 has no lowest form, well, that's nonsense. That's the nonsense. So if you assume that root 2 can be written as a fraction, you get that it is a fraction that does not have a lowest form. And that is just simply not possible, because what you can do is, the reason that's not possible is every number can be written as a product of primes. So say P and Q, if it's in its lowest form, write as a product of primes this, a product of primes, and divide out all the common factors. So that can't be reduced, and that can be done for any fraction. And here it's showing that no matter what fraction you have, you can always make it a lower form. So this is a contradiction. This is a contradiction. And so the conclusion, or actually not the conclusion, the assumption must have been correct. So this means that root 2 is not rational. I won't, just for space I won't do it, but it's contradiction, which means root 2 is not rational. Now can we perhaps, is this easy maths? In my opinion, no, it's not. It's a bit harder. Okay. So basically, just a little bit on proof by contradiction. There's lots of arguments about this. So what I'm saying is lots of arguments. There's different names for these things, but let's just say this is proof by contradiction. So this is a different thing. So say minus 1 is equal to 1. And then you square both sides, you will get 1 is equal to 1. And then you take away 1 from both sides, and you end up with 0 is equal to 0. Now this is a kind of a thing that you will see a lot of people writing. They start with something and they end up with 0 is equal to 0, and they say, oh, that means that's true. Well, clearly it doesn't. Here's an example where it fails. If you're doing maths where you end up with 0 is equal to 0, you're making a logical error. Usually it'll happen when you're trying to show that two things are equal. Well, if you're trying to show that two things are equal, calculate one of them, then go off and calculate the other one. If they happen to be equal, then they're equal and you're done. But don't start by setting them equal to each other. That's not very good maths. Instead, what you should be doing is, as I said, so this is just saying, okay, this is nothing. Now, the other possibility is if you start with something, so it's possible to start with nonsense and to end up with something true. What is not possible is to start with something true and end up with nonsense. This cannot happen as long as you make a valid argument. So if that's impossible, what you can do is, and I just want to show you this for a different reason, is if you start with something that you think is true, or actually what you do is it's a little bit different. So the proof by contradiction says, okay, you want to show something is true. Assume that it's false. Okay. all I want to say is that if you start with something, say -1 is equal to 1, and if you end up with nonsense, that means the original thing is nonsense. So for example, this is not possible is what I'm saying. So say here you add 1 to both sides, you get 0 is equal to 2. Now, why is that nonsense? That's a different question, but that is nonsense. And if you end up with nonsense, then the original thing is false. So this implies that -1 is not equal to 1. And this is the form that this argument takes. You start with something that's actually not true, or you start with something, you end up with a, well, it's not quite a contradiction, it's called a reductio ad absurdum or something like that. You basically, yeah, you just end up with nonsense, not quite a contradiction. This is just nonsense. And that means if you end up with nonsense, the original thing that root 2 is rational is wrong. And in fact,